I'm Arvind Nithrakashyap. I'm a co-founder and CTO of the company. I'll give you a very quick background of myself. Out of school, I started my career at Oracle, worked on core areas like database recovery, caching, was one of the principal engineers in the real application cluster framework. Did a bunch of scalability work. I don't know whether people remember the Superdome architecture. We actually had to, it was a very interesting project. We had to rewrite pretty much all of the recovery algorithm, make it scale on 64 CPUs. We laugh now, but at that time it was the largest symmetric multiprocessor.
Well, we only laugh now because you did it.
It was the largest symmetric multiprocessor available at that time. So that gave me a great insight into scaling a system for somebody a few years out of school. That was great learning. And then later at Oracle, one of the big initiatives I think actually both Vipul and I were involved in was simplifying the whole stack. And Oracle is not a simple piece of software to manage, as you guys know. And one of the biggest complexities is managing storage. I mean, there were different storage vendors. You had to kind of figure out how to tune Oracle for performance. And what we felt was, if we actually owned the storage stack, then it would make it much easier both to scale as well as to make it simple. And that was the birth of Exadata. So there were a few of us who kind of started the Exadata product and built out the first version. It's come a long way from the fries box that we put some disks in and started coding on, and it's a big $3 billion business right now. And I was there until we kind of released the first version of the product. Later, I kind of moved on to a few startups. Most recently was at Rocket Fuel, which is an online ad company, where I built out the real-time ad system. This was around the time that real-time bidding for online ads was just about picking up, and you had to build a scalable system that could scale to. We were handling about 50 billion requests a day around the time I left Rocket Fuel. Vipul and I kind of know each other from the Oracle days, and he in fact used to use the code that I wrote. In spite of that, we stayed in touch, and then kind of reached out to me, and we started talking about backup and the innovation, how there's been no innovation in the backup areas, and got together with all our co-founders, and that was kind of the birth of Rubrik. So before I kind of dive into the technology stack, two themes that you will see repeatedly when we talk about Rubrik is simplicity and scale, and that's what we've kind of designed. Simplicity. I mean, we are as consumers, we are kind of used to very simple devices. I mean, how many people here have lost or damaged their smartphone? Yeah, a lot of people have. I sent mine through a laundry cycle. So it came out really clean, but wasn't much use after that. But then I had my photos in there, I had my contacts. I mean, our lives depend on these things now. But I did not lose any data. After some desperate attempts, I finally gave in, bought a new phone. But all my data I was just able to restore all my data in a matter of 15 minutes. So the question is, why can't enterprise backup be the same? And that was kind of the core idea behind which we started this company. And then as an engineer, I'm used to thinking of, when I think of scale, I think backend, distributed systems, scalability. And when I think of simplicity, I think of like user experience, UI, and things like that. But really, these two things are kind of complementary. The reason restoring my phone was so simple was because I did not have to worry about how's the data stored, how much data can I keep storing backups infinitely. There was a scalable backend that stored it. I didn't have to worry about failure. Things can fail, but I still had access to my backup, right? And I didn't have to worry about buying storage beforehand. Things just got backed up to the cloud, and I just paid for how much I used. And so scale kind of makes, I mean, when you build a simple product, and building a simple product is hard, but when we build a simple product, it needs to be backed by scale. So when we dive into the architecture, you'll see that the components these are kind of the two themes that repeatedly play out. So what I'll do is I'll kind of run through the slides and kind of show you our technology stack, and then what I want to do is kind of whiteboard what you saw in the demo, and we can deep dive into detailed questions on that. So we kind of we break up our tech stack into kind of three areas. So what we call core is the layer that provides all the infrastructure for the rest of the components. So if you look here, we have a bunch of core services. All of these are designed to scale. our system is completely they're all symmetric. Each node has the same technology stack. They are all masterless, so you can lose a specific node, and the system continues to run as before. And all these components out here, I mean, we have a distributed metadata service that acts as the core metadata layer. We actually use Flash so that we have very quick response times for any metadata lookups. And this serves as the core metadata layer for the file system and all the other components that we'll talk about. This also stores the catalog data. So in any backup system, you need a catalog to kind of show what are the snapshots that you have and which ones you want to restore. So we don't need a separate database to provision. All of that's kind of inbuilt. Again, it's a scale-out system that is fault-tolerant and can grow as the system grows. On this side, we have the distributed file system, which is kind of our core, which is one of our core IPs. And the question is, why do we need a new file system? Typically, backup systems are optimized for capacity. So what they're trying to do is get in data, compress it, deduplicate it, and store it in as compact a fashion as possible. If you want online access to the data, you're really worried about how do you place your data, how can you very quickly give access to that data. What we needed was a system that could do both. Not only did we have to store the data as efficiently as possible, we need to be able to spin up any version that you have on demand. So we need a file system that could handle these diverse workloads and also be cognizant of versions so that it can spin up any version of the data you want. So the file system, again, is a scale-out file system, just like, say, something like the Google file system. As you add more nodes, you just grow the capacity, but it's still one single file system. You can log into any one node. You will see the exact same namespace across all the nodes. Two other core pieces, the distributed task framework. Data management involves a lot of, there's data lifecycle management. You've got to look at the data and manage the data. And this task framework is actually data locality aware. It knows where the data is laid out, and when it's scheduling any data processing, it makes sure that the jobs run on the nodes that are close to the data. And finally, the cluster management framework is the one that ensures that the cluster, however large it is, can continue to operate seamlessly in spite of failures, has self-healing, and also allows you to very easily grow the cluster. Any questions so far? Okay. The next layer is what is kind of the brains of the system. The data management layer handles the whole life cycle of your data, from ingesting the snapshot to maintaining snapshots based on the policy you defined, and archiving to the cloud based on what your retention is, and so on. And then the search, which basically lets you, as we ingest the data, it indexes the data and stores the index metadata in our system so that you can very quickly search and recover any files you need. And finally, this is the interface layer, which is these are kind of the components which lets us interface to third-party systems that we need to interact with. So what we call ecosystem integration is a layer that separates the hypervisor integration, and the Cloud Connect is about connecting to different cloud providers. So what we have done is we have separated out the interface part from the rest of the system. So the rest of the system is completely generic. So adding support for another hypervisor, another cloud provider, is just a question of adding another adapter, but the rest of the system operates as before.
And that's what allows us to actually support physical systems very quickly, because rest of the platform is not aware of virtualization or not aware of hypervisor. Hypervisor is just a definition layer, and once we get the data and pumps into the core platform, it's all the same. And it was done by design, because we built a brand new file system from scratch. The whole framework is built around like scalability and modern architecture, so that we provide a complete data management system where you are physical, virtual, containers, what have you.
Do you have already a kind of roadmap? And I don't want dates on the hypervisors, Hyper-V, KVM,
yes, all of them.
You're going all the way.
We want to support all hypervisors.
All hypervisor, all containers, and mostly use physical systems.
Mm-hmm. Cool.
I mean, yeah.
Yeah, and I can see where this, when we talk about the clouds, the self-service interfaces and stuff like that, that'll just plug in here as well.
Yes, yes.
Read a tenant model out of a.
Exactly. So adding support for a different kind of cloud provider is just another adapter.
Yeah.
Then we get the data, and the rest of the system
Hey,
operates.
I want to back up my OpenStack stuff.
Absolutely,
Done,
absolutely.
Cool.
Finally, the UI, as I think we mentioned in the demo, we explicitly took the design decision to say the UI will always talk through a REST API. We knew that programmatic access is going to be key, and a lot of IT organizations are moving towards self-service applications and programmatic access. So whatever you see in the UI is all it's doing is calling a REST API in the backend, and that's something we will expose for programmatic access. So any questions on this? Otherwise, I'll kind of just deep dive into the...
So what is the write factor on your distributed file system? Like how many times do you write the block or the backup data to your different nodes in your brick? Like, is it like a write factor of 2 where I write it once on one node on a second node in there?
Sure.
Is it 3? Is it something I can control? Does it change as I scale out?
So our file system handles the replication of the data.
Okay.
By default, we go with a replication factor of 3, but that is completely tunable.
Okay.
There's nothing. It's not fixed in any way. So that's completely configurable.
And then also, is it? I'm going to use the word block because is it block aware? So like if I have like two U appliances, will it spread them between the 2 appliances?
Yes. So in fact, let's say you have, let's say you're using 2 replicas and you have two physical boxes, then file system will ensure that one replica exists in one, other replica exists in the other.
Okay.
So we are aware of these failure domains.
Chassis aware.
Yeah. Okay.
That's the question you're asking.
Yeah.
Yes. Yeah.
Yeah.
Well, in a lot of ways, this seems like a hyper-converged provider with some of the. I can't think of the word I'm
We are not hyper-converged because we don't run application on our platform. Our platform is a backup storage plus backup software converged.
Thank you.
I'm thinking of a specific vendor, though the architecture seems very similar to.
Yeah, and Bipal was involved with Nutanix. So the GUI looks the same and the architecture looks similar.
I mean, it is all inspired by modern web architecture. If you think about what we are doing in this architecture is we are taking the Google stack of like conceptually inspiration of file system, task manager, like cluster manager, like data management, the whole stack, and we are putting it in a box and giving it to you with a green button to press it on and go. And system takes care of auto healing, replication, chassis awareness, all of it.
Okay. So what I'll do now is kind of what you saw in the demo. I'll kind of walk you through and kind of show you how different components in the stack, play with that. So typically we have a 2U 4-node box. Each box has some flash, some rotating disks, right? So one thing we did not demo is bringing the system up is actually in 15 minutes you can be up and running. All you need to do is bring this into your data center, connect it to the network. Our bootstrap sequence will take in a few IP addresses to configure the network, and then we'll take the vCenter credentials as Roland demoed, and then at that point the system is up and running. So basically you've connected to a switch. It's on the network. So let's say you have your vSphere architecture here. So you have some storage, primary storage, and then you have a bunch of VMs running here. You could have multiple such vCenters, maybe all sharing the SAN, maybe using a different SAN, and a bunch of VMs running in each of those. So you can add as many of these vCenters as you want. Immediately what the system does is it starts refreshing all the metadata from vCenter. It stores it in our metadata layer, and at that point all the VMs that you have in your system are available for you to protect. So what you saw was a list of VMs that you have in your system, and now you can choose to protect them. So once you protect them, what happens is so what you're doing is you're dragging and dropping these VMs. So you define some policies, right? And then you start protecting those VMs and kind of dragging and dropping them into different policies. So immediately what happens is our task framework kicks in based on the policy. It starts scheduling the jobs to start ingesting the data immediately. At the same time, it's aware of it's aware of the vSphere architecture in terms of what are the different hosts, what are the different clusters, and so on. So it is constantly monitoring the network, looking at different hosts that are at play, and it is basically throttling the. It won't go and overwhelm your system. It'll make sure that it's brought in a manner that has minimal impact on the production system. So the distributed task framework is also aware of how we lay out the data in our system. So when it's backing up a VM, it will try to run those jobs in the areas in the nodes in which the data is located, so that we're not also spending a lot of network traffic moving back and forth. So once these jobs are kicked off, they start ingesting the data. So that's where we ingest the data. We take a particular VM, we start ingesting the data. That's where we exploit Flash to ingest that as quickly as possible. So you can have multiple streams of data coming in, but in spite of that, you don't get this IO blender effect. You ingest everything into Flash so that you get maximal throughput in kind of getting the data. And the idea being that as soon as you're done with the data, you can ingesting the data, you can release the production resources back, and then so that you're not holding the production system hostage.
This is a very important innovation that we had in mind when we started the company, because today, if you are using VMware APIs to take a snapshot, and if you have a large VM, it stuns your primary application, and that's when you need to do array integration, and all of the backup software today is doing all of the array integration slowly one by one because they are technology limited. What we have done is, by intelligent use of Flash plus the convergence of backup software and storage into a single piece of software, the window over which we are keeping your VM snapshot open is so thin that the stunning problem that most of the backup software, if not all, face, we have kind of eliminated it for our customers. And we have a number of customers who used to do array-based snapshots and array-based integration, yet that is not needed anymore, because of this technology of parallel extraction of data in the Flash.
So as we ingest the data, so the data management layer kicks in, starts compressing and deduplicating the data. We also index the data. We also check the data for integrity. So if we see anything that's not kosher, we immediately will notify, saying that there's something that we're seeing that is wrong. So all of this process is done as we are ingesting it, and before we kind of distribute it to different replicas across the cluster. Once the data is ingested and we have done the compression deduplication, what we can do is we can then we hand it off to the file system, which then lays it out in a fashion and distributes it across all the spindles that it has access to. So the data is effectively laid out across all the spindles you have in the cluster. Now, as you run out of capacity, if you add another node, you've just increased the capacity. So then the system will automatically rebalance and move the data across a new set of spindles that you have.
And all of the data is compressed and deduped between hitting that SSD, that flash tier, before it hits the spinning racks.
Exactly. So what we store in the spindles is purely compressed and deduped data.
And all of the meta about that stays in the flash. Yeah.
Yes.
Now,
exactly.
is that a global deduplication across all your SLAs and backup jobs, or is it per?
No, it's across. So what we do is we look across all the snapshots we've ingested, and we dedupe across all of them. Because the key is it's a single system, right? It doesn't matter. You can have one node, 10 nodes, it's still one single system. So we have access to all the metadata about all the snapshots.
It's a single dedupe namespace. Okay. So as you grow the cluster and it gets larger, the namespace grows with it.
Okay.
So this is for the first time you have unlimited dedupe domain, so to say.
And this is a real challenge in the dedupe space, because in great platforms, like Data Domain, they started small, but they grew up. They that was how they scaled. Was they scaled up? They had no way to scale out. So you could only fit so much into one platform, and then you had to forklift and move to the next platform, the next larger box, right? And everybody's building bigger boxes, but nobody's really addressing it from a web scale architecture, and that's what we're trying to focus on here.
Another direction from Doug was how are you actually reading the data off the primary storage and getting to that ingest, because generally you'd either run a virtual appliance that's doing an attach to the VM disk, or what's the mechanism?
So we actually use VMware APIs. So we don't do hot add or any of that. So we ingest based on using the API, either directly from the SAN or through the host.
So for VMware specifically, that's we can do the VM copy over NBD mode. That's one option.
Right.
Or you can also do direct SAN mode by attaching the iSCSI or NFS data store.
iSCSI.
Yeah. So I may be a bit out of date, but that block copy was a pretty slow mechanism in the past.
You would be surprised at how fast these runs for us.
That's what I was explaining earlier. Because of the combination of flash and a converged platform.
Oh, it was the read side that was slow, was my understanding, not the write side.
So what we have seen is that we are limited to by your primary storage system.
Right.
And if the primary is so slow or an older system, then we start to throttle because we can overwhelm your primary.
Yeah. But if you have iSCSI storage, for example, we'll pull directly from the SAN.
Direct point. Yeah.
So I mean, it doesn't. I mean, in terms of storage, we just pull the data based on whatever your primary storage system is. So basically, so this data is kind of is laid out across all the spindles. The file system is also lays it out in such a fashion that later, if we want to construct any version of the data, it can very quickly collate them and present them to the user. One of the key things is all this metadata is maintained in this distributed metadata service, and again, that's running on Flash. So that's it's very responsive and very quick to store and retrieve data from it.
So we do first full snapshot and then incremental forever. But because the way we lay out the data on the disk, that if you go pick any snapshot interval or any snapshot time, and you want to say through our GUI or API, you want to say, I want to power this on. What we have seen is that it takes longer for VM to power on, like 30 seconds for VM to come up. We take like 1 second or 0 seconds sometimes. There's no real data movement, no rehydration.
You've already created the metadata for that point in time from the store.
So we just kind of start to assemble and give it to you, and then we assemble it on the fly.
And as you're reading the data, we move the hot data to the Flash. So you're effectively reading from Flash.
So all the temperature tiering, data management, and colder data, hotter data, temperature management is kind of automated. You don't have to. And these are the things that has to be built into the storage system if you're claiming to be powering on the VM. Otherwise,
your backup storage is primary storage as well.
Yes.
The key.
So you can't power on the VM unless you have that storage intelligence built into the platform.
Yeah, I mean, as backup software, you're still at the mercy of storage. You're still at the mercy of what your data domain or any other storage can perform, what kind of performance it can give you for when you mount a VM. So then that's kind of how the snapshot is ingested. So now as time goes by, based on the policy, we continue to take snapshots and store that in the system, taking incrementals once you've taken the first full. The data management layer again kicks in. It's constantly monitoring this activity, and then based on your policies, it's expiring older snapshots. And then actually, if you've set a cloud retention policy, it actually, once you hit that retention point, it starts moving all those snapshots into the cloud. And as we mentioned earlier, when we've designed the cloud archive to be self-contained, so the idea being that we send the data as well as the metadata along with it. The transport is encrypted. We store the data encrypted at rest based on keys that are provided by the customer.
Is that the complete metadata or only the metadata for the VMs that you move to the cloud?
No, this is actually what we store. Because our data is inherently tied to the virtual machines and your vSphere hierarchy. So what we store, we actually store a snapshot of the vSphere hierarchy. So let's say, for example, this box just goes away.
Yeah.
We can reconstruct the full hierarchy as well as the related snapshots from the metadata we store on the cloud. So it's completely self-contained.
Mm-hmm. Okay.
So even if your, for example, data center were to go down, we can still reconstruct all the metadata for you.
So 2 questions that came up here on Twitter quickly. from Michael Davis. The first question was, so if I have a VM like that has 10 or 15 disks, can I break up that backup job to say exclude certain disks, or only back up the first 10 disks in this job and back up 5 in the next job?
So we already have so when we have VM with many disks, we do ingest that data in parallel because there's no reason to kind of do them in sequential fashion. And again, we have these throttling mechanisms in place where we don't like again overwhelm the specific host. So we have the hooks in place to enable that. But what we have seen is typically it's best for the system to kind of adaptively ingest the data. Okay. And we have no problem ingesting how many ever disks you have.
And that question is really coming from this mindset of running jobs.
Yeah.
I mean, if you think about like backup application today, they are a Windows application writing to some other storage system. You have to run jobs to kind of take backup. Our mindset is, tell us which VMs you want to protect. Tell us how frequently you want to protect it so that your RPO is defined. Your RTO is 0 in our system. We'll do it in such a way that you don't have to worry about like running these jobs, figuring out like which disk go first, which disk go second, because this system is designed to make those things completely automated and efficient. So we want to move people to move away from this job-oriented framework and clicking here and trying to build scheduling yourself. System has built-in intelligence to do all of it.
So you can't specifically exclude a disk from a backup then?
If you want to exclude a disk, I don't think we allow it to do today.
Yeah.
If there is enough requirement, we can let you do that going forward.
There's nothing preventing us from doing it. It's just.
But it's not a use case we have seen.
So you would have to see customer use cases to turn that feature on.
Yeah, but we can enable that. I mean, that's a simple toggle.
But that is just the exclusion part. But how we schedule jobs, we don't want our customers to be worried about like scheduling jobs and thinking about jobs. We want them to think about policies, think about applications, what application require, define it and forget it.
Okay. The second question also from Michael was, in terms of like your file search across multiple disks or multiple VMs, how well do you handle NTFS mount points? So if I have a disk that's mounted as a point in another disk, it doesn't have its own drive letter.
Yeah, so what we do is since we actually look at the underlying file system, so we have the ability to deal with however the drives are mounted. So we have many customers who already have NTFS systems. They have multiple drives. They have different disks kind of mounted on specific VMs. And since we get all the data, we can scan through that. So that's not a problem.
So essentially, if I symlink a disk into another disk and it doesn't have its own drive letter, it just shows up as a folder inside.
Just shows up as a folder, yes.
So you'll still be able to search it and pull stuff back.
We can search for folders. We can search for file names. All of it.
Okay.
All of it.
But on a restore, you lose the symlink.
Yes, so if the data is not part of it, then I mean, so any manual hooking up of drives, once the VM is recovered, you can do the same thing again. Because obviously that data is not present with us. But if it's included as another disk in the system, yes, it'll be part of our system.
Any more questions?
Any more questions?
Okay.
So as I said, the data management layer starts pushing the data to the cloud along with the metadata. But once it has been pushed to the cloud, as we saw in the demo, you can continue to search for any files within it. That's because, again, all our index data is maintained locally. So we can very quickly, again using Flash and our metadata service, very quickly get to all the file metadata. And then once you have a version that you want, let's say it's in the cloud, the system will automatically go and fetch that particular file from that snapshot. So you don't have to bring down a 5 terabyte VM to get one file. That file, we actually have a way by which we can directly pull that data from the cloud. So
that changes the cloud economics, because cloud storage cost is cheap, transport cost is high. And we solve the transport cost, because if you want a 20K file from the cloud, as I said earlier, you can get 25K file from the cloud.
And some platforms really do have a challenge with that, because they have the image, but so then they have to pull down the whole image. Well, if you're your 25 meg MDF files in a 400 gig VMDK, well, you're pulling 400 gigs out of the cloud, not 25 megs, right?
Any more questions?
And at the same time, if you want one specific version of your data, which is also in the cloud, you only need to get that one snapshot. And again, we will only get the data that we bring in is dedupe. We will not bring in any data that's already kept locally. So we'll only get the deltas. So again, in terms of cloud economics, when you're not downloading a full snapshot to recover a particular VM. So once you do that, you can now recover.
There's a question here.
Oh, sorry.
No, but please go ahead. No, it was on the dedupe. Do you keep tracking your dedupe namespace if all the VMs, for example, are migrated to the cloud? You have a deduplication. You need to have a copy at least locally. Otherwise, you always have to go to the cloud to.
Yes. So our metadata will tell us what piece. So, for example, let's say we want to materialize snapshot as of 3 days ago. What our metadata locally already knows what pieces I have locally and what pieces are in the cloud. So then the system will go and fetch those pieces back and then stitch them together. And eventually, what we're doing is we're providing an NFS endpoint. Which with all these different pieces, and you'll have access to that. So it's basically a function of how much data is in the cloud. So obviously, the further back you go in time, the more data will be on the cloud and less locally. But we optimize for the case where typically you're accessing data that's recent, and we optimize for that to be very quick.
Okay.
And so finally, coming back to the so this is how we have stored the data, and coming back to recovering, as we talked about file recovery, and in terms of if you want to instantly recover any particular snapshot, what we do here is, again, when you say instantly recover to the UI, the file system then immediately creates an NFS volume. If when you specify a host, if that volume is not already created, it will create the data store on that host, and then present the data, and then it'll contact vCenter to go and create a VM that uses that VMDK file as its virtual disk. So then what we're doing is we're bringing up, so all you're doing as a user is one click, and you will see a new VM being created on your vCenter. And we talked about the two use cases, which is if this is a mount, you're not recovering, you just want to create a copy, we will bring this up with the network disabled. So then you can go and configure it with any other, whatever is the network configuration you need. If it's instant recovery, then we will actually, we'll power down the original VM. Obviously, we'll give some warning saying, sure, you want to do this. And then we will bring up this VM with the same IP address. So now your system is back up. So if you have a failure, within a few seconds, you have a VM, your system is back up and running off the storage. And then you choose how you want to recover your primary system. Any questions on that?
Any thoughts?
One, if I may. With the bottom two layers of your stack there, which is quite impressive, do you at one point in time intend to tackle something like SRM or provide something like SRM? SRM is definitely in our roadmap, and because you have the ideal platform to implement something on top of that.
So we'll actually have a runbook automation. See, the whole platform is designed to have the metadata layer as the centerpiece, with our own file system that is flash and rotating disk hybrid platform. So if you think about the sequencing of VMs, VM power on sequencing, things like that, it's like an easy addition. The hard part for us for the first 1 year and few months was to build the foundation. Now we have the foundation in place, and we are going to kind of continue to build all those supports on top of it.
And our metadata actually stores pretty much the whole vSphere hierarchy. So we are aware of VApps. We know what VMs constitute a VApp. So it's easy enough for us to add, say, okay, recover this VApp, and then we can build a runbook automation based on what are the VMs and what sequence we should bring them up. So
impressive.
I don't suppose you happen to be able to give out any sort of pricing
Let's just say if you want to buy, we'll not disappoint you.
That is
CEO
very,
answer.
I don't know if I like
Take American Express.
Everything else is American Express.
Right, not mine.
Well, it's not mine.
Is it platinum? Just checking. Or,
Does it need to be platinum to buy one of these? Is that what you're saying?
Tell us.
The Amex Black cards, yeah. There's been a couple.
We don't disappoint our supporters.
There've been a couple of questions floating out there. Somebody wanted to know if they can just do full backups on a schedule at all, if that's something you guys support, or if it's just full incremental or just incremental.
There is no need to do full backup in our system.
Okay.
Yeah.
That's
All
again a
backups are full
relic of
backups.
the past.
yeah.
I'm proxying this question. You know, like I think a lot of times when stuff like this comes along, you end up stuck in thinking about how you've been thinking about it for 15 years, 30 years, as you guys have put it, you know, like, yeah, and so it takes a little time to get around that. But, you know, apps are also stuck that way. The idea of, how about consistency groups where you can do multiple VMs together, or
that's where you start thinking about things like vApps and
Yeah.
you start tying the VMs together.
No, also we
Yeah.
have the SLA domain, so you can actually assign multiple VMs to the same SLA domain, so they get the same schedule.
Okay, so they'll happen, and that leads to one of my questions: how many parallel backups can happen at a time?
So there is no limit in our system. We are limited to by the resources
APIs
on
are
the
supporting.
resources on the primary system,
Okay.
and that's when we throttle because we worry that we can overwhelm the primary system.
So, I mean, one of the primary things, I mean, do not affect the primary system, right? So do not cause any, you want that
Yeah,
minimum.
you don't want a production outage because of
exactly.
backup.
We don't want to overwhelm the network.
Cause no harm is our rule number one.
Rule number one, right?
So
which
that
is
also differentiates you from most other backup vendors, by the way. But yeah,
I mean, we have seen that we are sometimes if we can do as much I/O as possible, we can flood the network. I mean, we can maximize the network throughput, but we don't want to do that because we want to be cognizant of how much data.
See, the thing is that our platform, since it is like designed for a scale, designed for performance, so the way we think about is that when we go into a new environment, cause no harm, instant recovery, instant data availability, and people don't have to go and muck around with our system to do these granular things. You
that
come
is so
to us.
hard. That mentality is so hard to get out of.
It's hard to let go of.
Yeah, I spend 15 hours. Well, I don't, but the idea that somebody spends 15, 20 hours a week as backup admin, changing tapes and all that stuff. And what will I do now?
Yeah. But think about
I don't
think about
have
it like
to do
this.
that. Like, am I going to get fired? Well, no. You'll go on to more interesting problems.
Systems like this, hyper-converged, platforms are doing this today. Where think about the admin from 15 years ago. He managed one or two or 5 or 6 servers. VMware comes along, virtualization comes along. Now he's managing 100 servers, right? These kinds of technologies are going to take that same admin and allow him to now manage 1,000 servers. Right? How do I manage 1,000 backups? It's really about making them more effective because the infrastructures are growing. He's not running out of work to do. It's just his work is going to change. And we have to, the stuff that can be automated and normalized, let's automate and normalize that so that it's almost invisible. And then now they can move on to even more productive.
I mean,
tasks.
our goal is to give the time back to backup admin. They don't have to work on Saturdays and Sundays.
Or they're not a backup admin anymore.
Right.
They become an admin in the pool of generalists that start to exist.
Yeah, I mean, the thing is, I mean, in our personal lives, we are used to having things being very simple right now. If you go tell the backup admin, you have to spend 15, 20 hours backing up your iPad. So what the hell are you talking about? So I think there's a mindset there. I think we expect things to work in our personal lives in a certain way, but in enterprise we think, okay, we have to go through all these processes.
Yeah, true.
And I think it's part of it is, I think once they see, but when we show these to customers and they see the value, they're like, okay, this is great. I mean, I can do so many better things with my time than dealing.
It changes their quality of life if you think about it. They don't have to kind of worry about Saturday morning, 4 o'clock in the morning, schedule this, keep checking. I mean, whether it has happened or not, it improves their quality of life.
There's chuckles or whatever, but that's absolutely correct. Like that's, and what I've been getting at why we started this whole conversation even before the stream was running with my question, a typical question to vendors: why do you hate me? Like, why did you build an interface and a system that is my adversary? And I appreciate it when people have thought the other way around, that you're here to help me, you're here to, so thank you.
Any other questions?
Any other questions?
Can you tell us more about the hardware platform, actually? What's in it? Network interface?
Yeah.
So hardware, go ahead.
Yeah. So basically, it's it's commodity hardware. We have each node has a certain amount of flash and rotating disks. Obviously, some CPU and memory, and so what we sell is a 2U box with 4 nodes in it, and they're all the same. And basically, the software that ties them together into a single cluster. So there's nothing. We have no hardware-specific hooks in our software. It's all just
all the
vanilla.
data protection, compression, deduplication, everything is purely commodity, industry standard hardware. Nodes even don't talk to each other internally. They all connect to the top of the rack switch. Okay. So it is true software controlled, software directed platform. And that's why it scales, because there is nothing in the hardware that ties us down. If a node fails, you take the node out, put in a new node, we'll auto rebuild the node. Systems keeps going.
As the cluster ages, and you bring in new hardware and age out old hardware, right? The file system, the software stays in place, right? But you can rotate the hardware through the life cycle of the system.
We have implemented like cool Apple Avahi interface to detect nodes. One click, you can add node, expand your cluster, shrink your cluster. I mean, we didn't show you the demo for it, but it is like super easy.
So adding a node, you go to the dashboard, you say add a node. If you've connected new nodes to the network, they'll all show up there, and you say, okay, select these, here are the IP addresses, add it to the cluster, and that's it.
What are the networking requirements for a node?
So I mean, we recommend 10G networking mainly for data access. I mean, we have some customers who work on 1G, but
is it redundant out of each node?
Yes.
Am I supplying my own? Is it attaching to my own top of rack switches, or? Okay.
Yes. So it just plugs into whatever infrastructure you have. But we have redundancy in each of the nodes in terms of network ports.
Okay. There's a question floating out there. Continuing with the full backup stuff. Turns out one of the guys that was thinking about that was thinking in terms of the recent VMware CBT troubles, where backups were getting corrupted and things like that with the CBT. How, given that VMware is not well known for its QA, how would you fix? Because the fix for that was basically to revert to fulls if you were worried about it, that sort of thing. You don't have that capability.
No, so we we do support that. So if we realize that we can't do change block tracking because there's some kind of VMware side corruption, we immediately take a full backup. The next one automatically becomes a full backup, and then we.
So I could force full backups if I shut CBT off for a.
So the system actually.
Not that you guys recommend it.
But
just not that you guys recommend it, but we're stuck between crappy apps and where we want to be. Like you guys. Like guys like me have to marry your stuff to.
The answer is yes.
Crap.
No, but it's
and.
It's a little harder than that, because what we do is when we detect this, we actually go and turn on CBT again.
Oh, do you? So don't give you guys administrator rights.
Obviously, yeah. If you turn off CBT, yes, we fall back to taking full snapshots. But the assumption being that yes, we do understand that things like this happen. So what we want to do is then in that case, then take a full snapshot and then start taking incrementals from there. So then we're still guaranteeing your consistency, but minimizing the amount of data.
The CBT problems, though, if I remember correctly, I wasn't affected by them directly because it was a VMDK growth thing. Once it exceeded a certain size, it failed silently, though. And so if you're going and turning on CBT again, you're thwarting my ability to.
No, but
But then again, actually, if I remember correctly, you could just reset the whole thing. And
yes. We detect the fact that we're not able to get the change data. So we actually get usually an error back from VMware. So then we say, oh, okay. So let's roll back. Let's go back to full snapshot. take a full snapshot again.
But in our system, even if we take full snapshot, since we deduplicate and compress, that there is no actual data growth in our platform. It's your transport
The cost is in the network.
cost in the network.
So the changes are being detected where exactly? So like if you have a CBT issue, if you have to roll back to a full snapshot, are you taking the full VMDK into your flash and
Yes.
then doing the fingerprinting and dedupe?
Exactly.
Okay.
Exactly. So I mean, what that basically means is that we cannot just query VMware and get the actual data that's changed since the last snapshot. So then we don't have any choice but to get the full VMDK back.
Because after that, we don't believe VMware.
Yeah, basically
And then we say, let's do our own work to make sure that people... The thinking process is that we are the storage system of last resort. So if you have trusted us with your data, we want to ensure that you have your data. Unless there is some catastrophic failure and VMware shuts down, and we try to ensure that you have your data.
Cool, thank you.
Oh, one more. Rubrik, is that in any way related with Rubrik's Cube? Or no?
Well, I mean, I guess it was inspired by it, but yeah, but basically I think we had a
Because
big...
that was a rather complex thing to do.
So maybe the inspiration is that don't make it complex.
Yeah.
Okay, thanks.
It's
But
just
Rubrik
like you.
means a new standard in Swedish. And our goal is to build a new standard for data management where we provide you a complete data management and a modern architecture for you to be able to instantly access your data, whether you are accessing it for recovery, for your dev and test, you're looking for a file, you're searching for a file where the data lives on the cloud, lives in your private cloud, public cloud, wherever is your data is always available to you.
Is there any plans to leverage the compute to do the restores locally, to spin it up locally? Like
There's no
KVM?
plan to do compute because we believe that the compute is better left to
Yeah.
vSphere. We want to be the data management platform.
Just wondering.
So no matter how big your vSphere environment grows, right, we want to have a platform that can scale to envelop it, right? So I love the hyperconverged platforms because they scale out and then we can scale right alongside of them.
And we want to be one platform one cluster that can support going forward Hyper-V, KVM, VMware, containers. You don't have to have multiple different products for different environment.
That'd be cool. One last question from the interwebs here. Do you guys support CBT Restore? That's a new feature that VMware's added or whatever. Change block tracking and restore.
There is no restoration in our platform.
It doesn't matter.
Oh yeah, true. Okay.
It's just mount.
It's mount.
Ricky, probably.
Yes, Ricky.
Old school
Again, this is an old backup thinking.
mentality,
Yep.
right?
Yeah.
There is no restoration.
It takes a while for all of us to sort
Yeah,
of reset.
absorbing
All
that.
that crap, all of the 15 years of crap and workarounds that we
Love
had
it.
to deal with.
I want to record that sentence.
Yeah,
Last
well,
15
it's-
years of crap.
15 years of all of this crap that I've had to think about. I've got to learn to stop thinking about it. Seriously, I've got to unlearn all
We
of
are
these
now the data janitors. We are mopping it out.
bad habits, you know. Like,